Okay, I think we are like, hey, good afternoon, everybody, and thanks a lot for joining this meetup. I know that there are folks not only from Bangalore but all over India and maybe some other South Asian countries like Singapore, Philippines, and Korea as well. So first of all, a warm welcome to everybody, and and thanks to all. Sorry. Yeah, and thanks for that our presenters who are doing the three sessions actually three talks today. It's been almost a year, exactly a year actually. Like last year February we met in Bangalore. And it was a great meetup that time. I got to meet all of you guys, and it was a great day. But nevertheless, we like nobody has thought that world would change so much in a 1 year. And nobody would have thought about COVID becoming a pandemic and affecting all of our lives, causing so much pain and distress to many of them, and maybe actually affecting the livelihood of many folks out in the world. um, but yeah, there are some silver linings as well. That for example the Apache Airflow has grown so much in last year that it's beyond beyond belief basically. We got so many new commits, new features, new contributors, and even new committers got added to our community, and it is growing way faster than than like in the past it has been. So there has been a lot of things were done in the last year on Airflow, like to start with, like Airflow Summit, which was a multi-week long summit, and I believe there are like 50 odd talks happened in those weeks, and it was a hugely successful event. And then after that, we got released Airflow 2.0. It's a big milestone for everybody. Um, and that definitely put up Airflow at the front seat for all the workflow orchestration tools out there. So yeah, huge thank for everybody who contributed in any way in getting this release 2.0 out in the wild. um, yeah so Okay, so I think yeah, that's it. I think it's a time to call upon our the first presenter, Vivek Pemawat. He's from Cloudera, and he's a staff software engineer at Cloudera platform team, and he and his team manages the workflow platform at Cloudera. And he gonna present, he gonna walk us through like what are the challenges he and his team has solved at Cloudera in achieving and creating a workflow platform on top of Airflow. So, hey, hey Vivek, welcome, and thanks a lot for doing this talk for us and for the Airflow community. Yeah, over to you.
Yeah, yeah. Thank you, Sumit and Kexel, for organizing the talk. Hey guys, a big welcome to all of you. And yeah, I'm very super excited to show my presentations on the workflow platform we have built using the Apache Airflow. Yeah, warm welcome again. Yeah, so I will start with this is our agenda for today's meetup and the presentation. So we will first go to the Airflow basics, and then we will go to the core components of the Airflow and the principles. Then we will discuss, present the workflow platform we have built, the technologies we have used, and the operational design we have, and some wrappers we have built on the Airflow to fit with our existing frameworks and the custom operators we have built. Yeah, yeah. And the last we'll have question and answer. Yeah, yeah. So we'll go with the basics. So what is an Apache Airflow? So it's an open source workflow management platform to programmatically author, schedule, and monitor workflows. Yes. So that's the definition where we see, okay, we have a workflow system and we can programmatically manage and schedule and run the workflows. So this is a short summary of the core components it has. So it has a web server, it has an executor and workers and scheduler as well. Now, with this actually the web server it provides us the it's basically a Flask-based server, which actually serves the UI dashboard, and the executor defines how to execute the task, and it runs with the scheduler, and the workers basically execute the task finally, and scheduler monitors all the tasks and the text which needs to be run, and triggers them. So this diagram actually shows, okay, here on the left we have the data engineer guy who's actually interacting with the user interface of the Airflow, and it actually runs the DAGs, or it schedules the DAGs, and basically see the logs and all the activities it can do using the Airflow. So some basic concepts I will go first. So what is a DAG, what is an operator, what is a task, and then we will go to the small overview on the Airflow. So the DAG is basically, these are basically some task basically which runs in a particular order, and it has some dependencies also defined in the task also, and it's written in the Python. So every DAG is written in Python, and it's easy to maintain for developers also, because yeah, it's widely used language, and it's not an XML base, so that's a good thing for Python lovers. And a DAG is basically an instance of a DAG for a particular logical date and time. An operator is basically a class. So you want to execute a task, you have to use a particular operator, which operator will define how to run a task to carry out some work. And task is basically, task is the lowest unit. So a DAG will have multiple tasks, and each task will do some operation or some activity you define based on your task. An instance of a task is basically the object which basically runs in a DAG. Yeah, so that's a short summary of all the basic common terms in the Airflow we have, and some principles of the Apache Airflow. So it's actually very dynamic. You can write the Python code and generate the dynamic pipeline generation, which allows us for writing code and then instantiates the pipeline dynamically. And it's very extensible. You can write your own operators. Basically, you can write your own operator as per your needs and execute the task. Yeah, and it's very elegant. I mean, it's very. I mean, you can use the Jinja template engine to basically parameterize and run the DAGs, and scalable also. So by scalability, it's a horizontal scalable. You can add as many number of nodes to the workers, and basically execute the task parallelly. Yeah. So this is a small dashboard where we can see there are on the left, we can, in the left column we can see there are multiple DAGs, and it shows a schedule also, the owners, and on the right we can see that the useful links, and a summary of in the last one it rained, and the green and blue red color basically showing us what was the status, failed, pass. So like this it has, and some tags also we can add which team owns what. Yeah. So this slide actually shows us a sample a task. So there are three tasks and the dependency also. So first task is actually, so these are actually sample tasks I have added for the demo. And here you can see the, when we define the dependency in the last, so it creates this type of UI in the graph. So yeah. So first task is basically using a Python operator where we have some parameters, the task ID and the tag variable name, and this is the task name. And in the last we have defined the dependency. Okay. After these two tasks, push one and push two, we are going to run the puller task. Yeah, and to parameterize the airflow, we have connections also. So we can use the connections and then make it variable. Like if let's say you are using one of the services, you are using some connections like connection to big data, any of the like Cassandra DB you are using, or Droid or Azure, any type of database using externally, or even services HTTP based. So you can configure here. Once you configure here, so in the code of the DAG, you can easily access the connections also. So you can anytime update them if required, and then no need to make a change in the DAG's code. Yeah. And this UI shows us, okay, It also provides us a Gantt chart, basically how much time a particular task took, and also we can run parallelly task also, so it shows us the overlap also here. Yeah, and this also shows, okay, this task is taking the longest time. So these actually help us to understand, okay, how we are parallelizing the task and which task is taking more time, and like these things. Yeah, so using the Apache Airflow, we have basically developed the workflow platform to meet our requirement, where we want to have a unified infrastructure to run the multiple infrastructure frameworks to execute the workflow based on our requirements. So we are running end-to-end pipelines, which basically do our complete testing of the system. And by running those pipelines, we are leveraging the easiness to develop the different infrastructure frameworks and use them. So this is our technology stack. This is our operational design. In the operational design, we are using the Postgres DB, and we are using GitHub to put all the DAX Python code in the GitHub repository, and salary workers are being used to run the task on the salary executors, and to sync the DAX with the GitHub. We are running the Gitsync containers to basically pull the latest changes. And for logging, we are using Elasticsearch and FluentDB. So I will go through one by one on each of the tech stack items we have used. Yeah, so this actually shows, we have on the left, we have a data engineer who basically interacts with the Airflow web server and execute the task, and he can commit all the DAGs also to the GitHub. Yeah. And in the bottom, we can see that all our tasks are going to the queue and they are being run by the salary workers. Yeah. So deployment, what we have done is we are using the Red Hat based OpenShift Kubernetes cloud, so OCP. So this with this platform, we are easily able to scale and manage our complete infrastructure, the workflow platform. And what we have done is we have used the Helm chart to deploy the airflow and to maintain the airflow and also to scale also. So we have defined how many workers we need to have, and based on our usage, we are more and more adding more and more workers. Yeah. So here in the first snapshot, it shows, okay, we are running the Kubernetes and we are using the OpenShift Reddit-based platform. Yeah. And for distributing our workloads, we are using Salary. So, and we have used Redis as a message broker. So Airflow, basically all the tasks and which want me to be executed, so are stored in the message queue broker, basically Redis, and they are being run, and we are able to horizontally scale the workloads using the Salary executor. Yeah, so this actually helps us to scale the workloads and also manage it easily. Horizontally scalable also it is. Yeah. Now, one of the problem we faced is the logging. So logging is very critical for end users, and we want to have a system which is not tied to the Airflow also. So what we have done is we are using FluentD as a log collector. So this actually an open source data collector which streams the logs of Airflow services and the Kubernetes pod we launch to the S3 and Elasticsearch. For streaming, we are using Elasticsearch, and for log storage, we are using so for log storage, we have an S3. So all the Kubernetes pods we launch. So Airflow basically provides us the Kubernetes pod operator. So since our infrastructure is running on Kubernetes, so we heavily use Kubernetes pods to make our Docker images and run the Docker containers. And finally, for uploading the logs, we are using S3 as a storage. Yeah, so all the pod logs are streamed to S3. So this really actually helps us to, if let's say something goes down or up, but the logs are always available. So it happens because infrastructure is sometimes not reliable. Your Kubernetes pod can die and the logs are not streamed well. So we all to provide us the reliability to our end users. To so what we have done is we use this Fluentd to stream our logs, and S3 is used to stream the logs, and it actually streams the logs after some particular time period we have kept, and it's helped us to view the logs. And for the services now, as a Airflow, I mean, to maintain the workflow platform, we have to run multiple services. So it uses PostgreSDB, it uses worker salary, and we have the Redis also running. So it's not easy in the containers to check the logs, because containers can go up, I mean, up and down. It can restart also, but we need to have a logging always to check what's happening with our infrastructure. So we stream all our services log to Elasticsearch. So this actually helps us to check the logs live, and figure out the root cause of any issues we are facing in the infrastructure. And yeah, and the most important thing is now we have logs stored in S3 now to provide easiness to the end users, to check the logs easily without interacting with the S3 authentication. So what we have done is we have used Nginx as a proxy, reverse proxy. So this basically downloads the log for our end users and provide. So we have provided them web URL. Okay, HTTP based URL. Go and check logs here. They can easily check all the logs in the Nginx proxy. So this basically helps us to for our end users not to do make any changes on the S3, and provide them only read permissions. So, and also it act as an this proxy acts as an securities. I mean, it should not be made public also. So that's how we have done now. So this is a summary of the overall technology stack we have used. For the deployment, we are using Red Hat based OCP, and we have the deployment completely running on that. And for the DAGs, we are using GitHub with Garrett as a review system. So whenever you want to make any change, when you want to make any new DAG you want to add, so users just need to go to the GitHub and make the commit there. And finally, they can run the DAGs using the dashboard, actually, the Airflow dashboard. Yeah, for the logging, as we discussed, we are using Fluentd for an S3 in Elasticsearch. And yeah, the most important one more thing customization we have done is the reporting. Now, for reporting, we have our internal engineering dashboard. So what we did is we used the feature of operator of the Airflow, and we developed our custom operators to do reporting. So that basically do the reporting our system test cases, what we run, what is in failed, to the internal dashboard using the. So we have developed the custom operator for that, and that actually uploads the results. On the Airflow side, we are using Postgres as a metadata DB. So all the DAX information, all the UI which we see for the Airflow, it actually getting data from the Postgres DB. And the salary executors are used to execute our task, and the Redis is used to as a broker for the salary executor, and scheduler Airflow scheduler we are using to monitor all the tasks in DAX, and run the DAX also. Yeah. So reporting, yeah, we just now discussed that we are using custom dashboard operator, and we have implemented internally to fulfill our requirement of easiness to provide the links also. So whenever there is a run, we provide the running link of the Airflow and then check from there. Yeah. We'll go some more deeper into the operators concept here. So operators are very useful, and it provides, I mean, we can easily customize our requirement. So these are basically, this actually runs, what needs to be run is defined by the operator. And for each task, we have to define an operator, which operator to use, and to run in the correct order, we have to define the DAG order. I mean, we have to define the dependencies in the DAG itself. Yeah. So all the customization related to our infrastructure. So we used to have multiple infrastructure frameworks developed in the past. So some team were using Jenkins job, some team are using microservices, and some teams were using Docker containers. So now it was not easy to run all of them in a single workflow. I mean, it was not easy because some needs an authentication, authorization is needed. So what we did is we developed the custom operators, and finally the tasks are being executed by the service itself. So we have microservices which actually execute the task, but to make it a single workflow, we develop the custom operators and they basically execute the task. So yeah, we heavily use the concepts of operator and easily onboarded to the Airflow using this operators concept. Yeah. Yeah, some of the custom operators we develop like dashboard reporting operator, the quas operators. We have our internal infrastructure as a service, so we develop the operator for those actually. And for reporting also we develop the operator, and we use S3 to basically upload our reports to the S3, and then finally upload the results to the dashboard also. Uh, Yeah, and some of the open source operator already available, like bash operator. If you want to run execute a bash command, if you want to run a Python function, you can use the Python operator, and there's simple HTTP operator as well. And to interact with the DBs also, there is a micro MySQL operator, and then Postgres operator are there. And one more important thing which we use is the sensors. So sensors actually is an operator that basically waits for a certain time. Okay, it polls actually, and this helps us. Okay, if one of the tasks is completed or not, to check with other services. This provides us very easy integration. So we have developed a custom sensors which basically checks okay if the task is completed or not, and then based on that, the next task is executed. And yeah, we heavily use the Kubernetes pod operators over end-to-end pipelines. We heavily use Kubernetes pod operator, and those provides an easy way of integration of our pipeline because people basically, the users basically develop their own containers, images basically, and they test them, and then finally run in this workflow. Yeah, and one more customization which we needed is so we have our own way of execution. Now we want to execute some DAGs from externally. So what we did is we uh, we developed a wrapper over the Airflow, so which basically a Python based, and which basically you can call the which basically calls finally the REST API of the Airflow and execute the task. So this is really helpful to integrate with other systems also to start with. So you might be having your own infrastructure, but you cannot move all the infrastructure to Airflow. So what we did is we developed some workflow runner, basically a wrapper. A wrapper basically executes the DAG and it's wait till the DAG completes, and this actually gives us status okay the DAG is failed or passed, and it helps us to integrate with other systems as well. Yeah, this is a complex pipeline we are running where we create the data lake cluster. So this is actually custom to our requirement of different teams. So they have created and they are maintaining, and we are providing the platform actually. So they maintain their own image and they execute the task, and we just provide them the infrastructure, any issues we have, any new features, any custom operators. So we provide them as a workflow platform. So this actually helps us. Okay, one of the team is managing the platform, another teams actually developing their own. Based on the task, they define their own workflows. This helps us to scale easily with the teams also and provide them the new features as well. Yeah. Yeah, thank you for attending. Yeah, now any questions and answers we can discuss. Yeah.
Hey, thanks. Yeah, thanks, Vivek. That was really good to know, and like really helpful to know the insights of Airflow at Cloudera. I have a couple of questions I think from the community, so maybe I can start with. So the first thing is like you mentioned that you are saving the logs, the pod logs to S3. it's like that streaming of the logs, right? So are you guys only storing that the task log also, or you are also storing the process log, basically, like that the work
Yeah.
schedule, like scheduler
Yeah.
web server logs also.
Yes. Yeah. Yeah. Thank you, Simon. That's a really good question. So we have integration. We are using the custom logging of Airflow. So all the
Mm.
logs are streamed to S3. But we face some issues in the Kubernetes pod operators. Sometimes when the Kubernetes pods are running for a long time, for more than an hour, so logs are not streamed to S3 by Airflow. So what we did is to provide the reliability. We are extra doing, streaming all the logs to S3 using the Fluentd. And
Okay.
since services we need live, for every 2 minutes, we actually what we do is we stream the logs with Elasticsearch, so that we can filter based on the timestamp and based on the keywords of the services. So yeah, for streaming we use Airflow, basically Elasticsearch, and
Mm.
for pod logs we are streaming to
Mm.
S3. And Fluentd is used as a data collector, basically log collector, and it
Okay,
runs
got it.
so it
Yeah.
runs as a daemon. There's no change in the complete platform.
Nice. And like the similar question, associated with the same question, like what is the life cycle of those logs at S3? Like, are you guys keep them for forever, or like you kind of get rid
Yeah,
of them after a certain time?
yeah. Yeah. So what we did is we keep it for a month time, and
Mm.
S3 actually provides us a bucket policy, lifetime
Mm.
policy. We configure that, and automatically the logs are getting deleted. Same is the case for Elasticsearch. What we do is we create the index based on the time date, and after every 7 days, we used to delete the indexes which we don't need. So this actually helps us to easily scale, because if the logs are very heavy and they are accumulated over the time, so automatically the cleanup is there. Yeah.
Yeah, makes sense. Yeah,
Using
perfectly. And
yeah.
got it. Got it. Great. The another question I had around, you mentioned about, a couple of operators which you guys have built at, at Cloudera, like in-house, right? So are those operators are like, open source already, or do you think that there is any value, that is it a value thing to do, like make them open source and can be used by the other folks out as well?
Yes, yes, definitely, yeah. So currently our dashboard is it's internal dashboard, engineering dashboard, which is used to see, okay, how many tests we have run in a week and see the release, what products we can release. So that's little internal right now. So what we did is we developed, currently it is for internal purpose, basically internal reporting it is there right now. Yeah.
Hmm.
But yeah, if we
Okay.
use some open source dashboard, then it
Hmm.
really makes sense to make that operator also as an open source. Yeah, that
Makes
makes sense.
sense. Makes sense. Okay, got. Yeah, I think there's a question from the YouTube chat as well. I think you can read that. And yeah, how is the integration of Airflow task reporting with internal Cloudera engineering dashboard done?
Yeah, so what we have done is the for all the tasks, so all the tasks are running in a DAG. So what we do is at the end of the task, at the end of all the tasks, we have an reporting task, which is developed using the reporting custom operator, which basically downloads the log from S3, not logs actually, the reports, and it actually submits the report to the internal dashboard using the REST API. So we developed a custom operator, and the task is executed at the end, and it do reporting of all the tasks. So it takes care of like when you rerun the task, so it actually
Mhm.
reports with
Yeah,
a time number also, because that's really important and that's really very good feature of Airflow. We really love that feature. You can rerun the task. Like if you use other modules, other technology platform, it's really hard. If you use Oozie, if you use Jenkins as a pipeline, maintaining a pipeline and then rerunning the task, it's really difficult. Yeah.
yeah, totally agree. Yeah, maybe this is the last question we can take. Yeah, so thanks, Vivek, and could you please advise, Airflow upgrade strategy that you follow in your OpenShift environment from
Yes,
Siddesh?
yeah, yeah. For upgrade is really very critical. So what we do is we use the features of OCP. We deploy using the Helm charts, and we are easily able to upgrade using the Helm charts actually. So we are running the pods finally in the OCP, and we use the upgrade strategy, and then we upgrade the Airflow platform. Yeah, workflow platform.
Okay, got it. Yeah. Yeah, with that, I think that's it for the Q&A session. Yeah, thanks a lot, Vivek, and it was a really nice session. And yeah, uh, thanks.
Thank
And
you everyone for attending. Yeah, thank you Sumit and
yeah,
Axel again for organizing. Yeah,
yeah,
I will hand over to
yeah,
next.
sure, sure.
Thank you all.
Um, Yeah. So great. I think so. With that, I just want to remind quickly that if you have any questions regarding the talk ongoing, you can just feel free to ask that question into the YouTube chat. On the channel you are watching right now. And after that, I would like to call upon Kaxil. So he's just gonna walk through little bit update about the Airflow 2.0 and maybe further roadmap, and we're gonna have further talks down the line. Hey, welcome, Kaxil.
Hey Sumit, just a second before I share my screen. Nice. Let me just pick the correct slides. Hey, thank you Sumit for organizing, and thank you Vivek for the nice first talk. And yeah, it was an interesting last few months. We released Airflow 2.0, which, like Sumit said, is one of the big milestone for the project. And that's what I'm here to tell about. Like, not give you all the details about Airflow 2.0, but to tell you guys that you should update to Airflow 2.0 as soon as possible. And the reasons are mainly these features. Like, we have the refreshed UI, lots of performance improvements, like the scheduler high availability. You can run multiple schedulers, stable REST API. You can do everything that you can do right now from the web server. You can do via the stable REST API. The new way of writing DAGs, which is like the task flow API. You can use decorators, like decorator for a DAG, decorator for a task, making it very seamless to write a DAG. And an added advantage that you can also do XCOM pull and push with natively, instead of knowing how the syntax works, and separation of provider packages. Like, those are the main things. I will just quickly show you few things about those features, like a refreshed UI. Whole, like, this is the old view, this is the new view. You can see the difference. Like, it's not huge difference, but it's still refreshing. And the main thing is not this but this, like the graph view, the old graph view. Remember how you, if you want to see the task status, you need to constantly refresh your graph view and see, okay, did my task succeed, did it fail? The new UI has an auto refresh button, and it will automatically refresh your task states every so often. So this is one of the biggest reason I have seen users that upgraded to 2.0 loved about this. Yeah, the performance improvements, quickly talking about that, like, most part of the scheduler was rewritten for as a part of the scheduler HA work. And like, the scheduling logic has been separated from DAG parsing logic. So now DAG parsing is no longer tied to scheduling. That means that there won't be any scheduling delays because you have something in your DAG file. And significant improvements in code to fetch something from metadatabase for web server, for scheduler. And we are trying to do as much as in batch as possible. Like, these are the numbers. Like, we at Astronomer carried out benchmarkings. We have a QA team who did an excellent job of benchmarking with various bash operators and various kind of scenarios, like different shape, different kind of scenarios. Like, you can see that there are like 100 deck files, one deck per file, and then there are like 10 deck files and 100 tasks per deck. But like, configuration for all of them was same, like 4 salary workers, one Postgres database, one web server, one scheduler, and they all ran for like 1,000 tasks per run. And the difference between 1.10 and 2.0 is significant. Like, what took 200 seconds, like almost 3 minutes on 1.10, took just 11 seconds in 2.0, which is a huge improvement. And A highly available scheduler. So scheduler was one of the bottlenecks for 110x series. Like if the scheduler goes down, everything would stop. From 2.0, that is no longer the case. You can run as many scheduler as you want. We have resiliency and scalability. Because of that, the task throughput certainly increases, reliability certainly increases. We have tried killing the schedulers, lots of different things, and everything has still worked. So that's one of the things. But remember that there are database requirements for it. It only works for Postgres 9.6 and MySQL 8.8 plus. If you want to leverage multiple schedulers, like it would still work for MySQL 5.7, but you won't be able to run multiple schedulers. The single scheduler will work fine, and this is mainly because we use row level locks for the scheduler edge stuff, and those SQL syntaxes like skip, no wait, and stuff like that, they do not exist for MySQL 5.7 and MariaDB. The main reason for using row level locks was that we didn't wanted to use like additional components for uh, the higher level because it's maintenance burden. Yeah, this is the rough architecture. I'll share the slides that will be available in that. And the scheduler now uses text serialization. If you remember 110x series, you had an optional feature that the web server can use text serialization. From 2.0, it's mandatory. Like it's no longer optional. The web server will use text serialization. The scheduler will also use text serialization. So the DAG parsing process reads the DAG files, saves the serialized DAG into the database, and the web server uses that, and the scheduler uses it for doing its scheduling decision. Um, yeah, and one of the questions I've been asked a lot about how should we go about upgrading to Airflow 2.0. So these are the steps, like install the latest 110 release, which currently is 110.14. Install the upgrade check package. So we did some work on creating this package. This is analogous to Py223 script. So if you download this package, Apache Airflow Upgrade Check, and then you can run this Airflow Upgrade Check command, we have a bunch of rules that would show up and tell you that, okay, you need to upgrade this, you need to change this, or this is deprecated. So this should be the first step. And fix any warnings that the checker shows, and you should be good. But beware that you should also read the upgrading to 2.0 guide and the updating.md, because there might be subtle changes that are still not covered by the upgrade check package. So you might want to read those carefully before upgrading, and then upgrade to Airflow. If you find anything that does not work, reach out to us on GitHub issues. And as of Monday, I think we released Airflow 2.01, which contains a lot of bug fixes from 2.0 already. So instead of going to 2.0, you can straight away go to 2.01. There are like a lot of bug fixes and few more performance improvements. And yeah, normal links and about Airflow, documentation, Slack channel, Twitter, and feel free to contact me if you have any issues. Thank you. Is there any impact of DAG serialization use on the metadatabase? There, the load will certainly increase a bit, but overall the performance will improve and it won't be worse than 110x. So that's for sure. So while the load would increase, but because of other optimization, it won't be significant, I should say. Another question is also, how can I use salary executor with subdag operator? So that's an interesting question, and maybe I didn't cover it because I wanted to make this very quick. But from Airflow 2.0, we have something called task groups that are meant to be a replacement for subdags, because subdags have been known for lots of limitations and gotchas for it. Like pools are not honored. You might face deadlocks if you over allocate stuff. So that's why I'll send the slides, but you can search for task groups on the Airflow documentation for 201, and you will find that they are a nice replacement to subdecks. Mainly, the task groups are UI only concept. The concept for grouping task in the UI instead of subdecks, which are like a logical separation. And yeah, I don't want to get into details currently, but use task groups as much as possible. Subdecks would might be deprecated soon. We are trying to see that task groups are with featured parity to subdecks operator. And once it reaches that, we are going to remove subdeck operator. Cool. I think we are done for questions. Then let me invite the next speaker, Jilan. Hey.
Hi, Kexil. Hi, Sumit. Can you hear me, please?
Yes, we can hear you. Thank you for joining. So Jilan is the lead developer and Scrum Master for the Airflow team at Societe Generale, and he's going to talk about Airflow artifacts deployment. So over to you, Jilan.
Okay, thank you very much, Kexil. Great. I will share my presentation. Just let me know once you can see it.
We can see it now.
Okay, great. So perfect. Hello, everyone. Very good afternoon. Today, I am delighted to present how we are using Apache Airflow as an orchestrator at Societe Generale. This is today's agenda. First, a brief introduction, and then we look into Airflow as a service offer at Societe Generale, and then we see how we are dog fooding Airflow. And we deep dive into our deployment strategy. After that, we look into our internal idea to have unified UI for Airflow. At the end, we do some Q&A. So please keep posting your questions. So I am Jilan Kotakota, and I am a lead developer and a Scrum Master for Airflow team at Societe Generale. I have more than 8 years of work experience, and I've been working with Societe Generale for more than 4 years now. You can connect with me on LinkedIn with this ID. So, Societe Generale is one of the leading European financial services group. It is founded in France in 1864. It has presence in 67 countries with employees around 150,000 globally. For over 150 years, Societe Generale has been inventing and developing its businesses, services, and banking products with a clear vision of future. So we are part of Global Technology Services, whose mission is to provide secured infrastructure services for the group's business divisions.
Hey, Jilan,
So
just
as part of the digital transformation, it
sorry.
is committed.
Yeah, interrupting mainly because I think you might not be sharing the correct screen. So we are seeing your PowerPoint screen, but the one that is not full screen. So not sure if you intend to share that one or the other.
Okay, I think just a minute, please. Sorry for this. Let me stop sharing and then share again.
Sure.
Just can you see it now?
Yes, we
Nikhil?
can. We can. Yeah.
The full screen one, right?
Yes. Yes. Yes.
Okay, great. Sorry for that little interruption. Okay, so where I stopped, okay, as part of digital transformation, it is committed to an open innovation approach. So this allowed us to introduce Airflow, Apache Airflow as an open source orchestrator at Societe Generale. So before we go into Airflow as a service offer itself, let us look at current Airflow tactical solution, which is based on VMs. Currently, we have more than 50 customers with more than 20 Airflow instances running in production. Also, we have provided more than 80 developer stacks our environments to different developers to have hands-on on Airflow and to do their POC for their use cases, so that they decide whether it is suitable solution for them to migrate to Airflow. And these are a few use cases for which our customers are using Airflow for. For example, they're using for job scheduling, ETL orchestration, auto remediation, and patching. And also some of the feature teams are using as a control plane orchestrator in their service. So with growing demand and to reduce cost, we have come up with an on-demand Airflow instance provisioning solution, that is Airflow as a service. So the customers for this new service are all DevOps teams internally. The product is fully managed container Airflow instance. We used containers to leverage the power of Airflow for its scalability, and to reduce cost also. For hosting part, it is entirely hosted on internal platform services, and is available on all trusted networks. So now we look at what are control and resource planes, and how to consume them. So let's take a real example. As a client, I will use control plane API or self-service portal to request for a new Airflow instance. I will use an internal IAM account with required scope to authenticate. And after that, I will provide all the required inputs, like name of the instance, size of the instance, etc., and then execute the API. So the API triggers our control plane workflow, which provisions an Airflow instance. So once the instance has been created successfully, I will use the Airflow RBAC user to connect to newly created Airflow instance. So with that, let's take a deep look into the first part, that is control plane API. So these are the endpoints we have in control plane API. We can focus mainly on instances endpoint, which is used by user to create Airflow instance. And we can also update or delete the instance using this endpoint. On top of that, we also have endpoints such as queues users for configuration purposes. So what happens in the backend when user request for a new Airflow instance? Suppose as a client, I have requested for a new instance using our cloud platform portal, which is similar to AWS Marketplace, but it is internal to SG. So it will forward the request to our CP API, control plane API, which in turn forwards the request to our provisioning workflow with all the information required. So for this part, we are dog fooding Airflow, which means we are using Airflow to provision an Airflow instance. So entire provisioning workflow is described into a DAG. So we will take a deep look at this provisioning workflow in the coming slides. Once this workflow is triggered, it looks for dependencies like version of the Airflow to be installed and the configuration and etc. So, and also it looks for some data set, SR set, and as it uses Celery executor, it requires a broker, metadata DB, and a backend result. So once we gather all this information, we use Helm charts to deploy over Kubernetes, and we update control plane DB at all the stages of lifecycle, so that a user can get more information about his request at any point in time. Okay, so how we are hosting this? As I said earlier, so we are going for a fully containerized instance. So we are dog fooding some of the internal internal service, that is container as a service, to propose all the services under Kubernetes. So we have the control plane, and we have an Airflow application which will be used to provision Airflow. So we are also dog fooding other services, as we are consuming Postgres and RabbitMQ. So we are pushing logs into metrology, metrology service, and then we are also using secret service and IAM for different purposes. So once we provision this instance, we have to consume it. As you know, we have the basic Airflow UI, and an experimental API. When I say experimental API is because we are using Airflow version 1.10.2 still. So as it is a basic one, we had to develop a new API internally. So this API gives us the possibility to perform more operations over the DAG. So we have special endpoint deployments endpoint which will be used by the developer to deploy the artifacts, like a new DAG has been developed and its dependent packages and everything. So similar to control plane, we are hosting all the stateless components of resource plane on Kubernetes, and stateful components using Postgres and RabbitMQ. For this, we are again dogfooding different services, internal services. Right. So I have been saying dogfooding all the time. So what is this dogfooding? So anyone know what is it? I hope most of you know what is dogfooding. So it is a simple but quite powerful concept. So it means internal usage of company's own products or services in its day-to-day operations. So which means if the product is good enough for the consumers, and it is good enough for its employees also to use on their day-to-day job. So that's a very powerful concept, and I would suggest you to use it. And let us look how we are dogfooding Airflow using provisioning workflow. So when a client submits a creation request for a new Airflow instance using control plane API, the request is registered into control plane database, and on the other hand, we have an Airflow instance as the control plane orchestrator. So we have Polar DAG, which polls on this control plane database for new requests for every 5 minutes. So once we have a new request, it routes the request to different DAGs based on the action to be performed. So it can be for this purpose. Actually, we are using custom trigger DAG run operator. It is a custom one, and the action here can be create, can be manage, or can be a deleting an Airflow instance. So let us see what happens when a request for create instance, when we have a request for create instance. In this case, our Polar triggers create instance DAG. So in the first step, it passes the payload for the required inputs. Once the inputs are validated, all the necessary resources such as Kubernetes workspace, broker, databases, and everything are provisioned parallelly. Then using Helm charts, we deploy all the containerized Airflow components such as a web server, scheduler, workers, etc. So once artifacts are successfully deployed, we create an admin account for the customer. So at this point, at this step, we generate password at the runtime and write it to customer's vault namespace. So when I say that, and we won't have his credentials to log into his instance, so we respect the privacy and security. So apart from this, we also create required SSL certificates for the newly created Airflow instance. So once the instance is created, a client can deploy his code using deployments endpoint on a resource plane. Just some time back, we have seen on the resource plane. So to understand how the deployment is done, let us look into the controller, which is the masterpiece for our deployment strategy. So let's take an example again. As a developer, I have all the code and dependent packages to be pushed to Airflow instance. I will ask resource plane API to deploy these artifacts, and then the API will put this event into the queue. And on the other hand, controller is polling on this queue, and once it has a new event in the queue, it uses excuse me. So it uses Scaffold, which is a tool provided by Google, which simplifies the work with Kubernetes pipeline. So we will just build a new image with with all the dependencies and push the image to Docker registry. So in this step, we also perform a compliance check on the image before pushing it to registry, so that we will not have any vulnerable image in production. So after this, we will deploy it our Kubernetes cluster using Helm. And we also push the logs into SG internal data lake using FluentBit. Okay, as we have seen, our deployment strategy is based on building a new image. We all with all the required dependencies every time a user requests for a deployment. Let's see how the image is built. So on the first layer, we are using internal hardened CentOS base image. On top of that, we are installing Airflow and dependencies. So once a developer requests for a new deployment, we use Airflow base image, and we inject all his dependencies like Python packages, system packages, or any environment variables, and we build a new image, that is SG contributor Docker image. So at last, we are using this freshly created image to expose other services. Okay, so that's what about the deployment strategy. So let's talk about our new internal idea we have for unified Airflow UI. Actually, we will first analyze what is the current scenario. So as of today, even for customer or developer, we have a lot of UIs. Like we have Airflow UI, we have Flower UI, we have UI for the deployments, we have UI for the logs, and etc. So, and on top of that, we have to authenticate for each of these UIs separately. So there is no single sign-on. So as you know, it's frustrating and hectic to go to all these UIs and authenticate every time, and go through the different operations in day to day. So we have faced this issue, and then we have come up with an idea to have why don't we have an single page for all of these things. So that is when we are trying to build a one-page UI where we will have all these options to navigate between the different UIs without authenticating separately each time. So we'd like to have this navigation bar, and then once we authenticate one time, then we can seamlessly navigate to any other UIs. So I will just show you. This is the draft one. Actually, it is still under development. So as you see on the left side, we have a navigation pane, and we have different icons like Airflow UI, API, Flower UI, and all the icons. And from this page, we can seamlessly go to any of those UIs, and we don't need to authenticate again. So once this development is done completely, and we would like to contribute this to the community, so hopefully it will help to the other people who face the similar issues. Okay, so that's it from my side for today. We are at the end of my presentation, so if any questions are there, we can answer.
Hey, thanks for that, Jilan. It was a really nice talk. Yeah, let's take some questions. So I had a question.
Okay.
You said about HashiCorp token, or I saw it in one of your diagrams that you use it for vault tokens. So do you use HashiCorp vault for Airflow secrets too, as in the connections and variables?
Yes, so some of the customers, and we are also using Vault, and we are integrating this into airflow.cfg, the Vault configuration, and then we are using in our DAGs.
Awesome. Right. Um, Yeah, and do you manage those like secret rotation every so often, and or that is done by your infra team for Vault?
That is by us. Actually, we have another internal service for Vault. Again, we are dog fooding there, and it is our responsibility for our secret. So we will be taking care of this rotation or whatever you said. So it is our responsibility. So for now, we don't have any fixed period after which we have to do all these things. But yes,
Right.
for future, maybe we can think of.
Okay. Okay. Next question from Sumit is: what is the significance of polar dag?
Okay, so significance of polar dag, it's a good question. Maybe I can go to that slide, or if you can remember, from control plane API, we are registering that request to control plane DB, and from there, Polar is reading. So you can ask me why we need this polar dag, and why don't we directly call our different DAGs from control plane API itself. So suppose if our control plane orchestrator is down, so when a user comes and he requests for a new instance or deletion of any action, if he wants to perform, it will be failure straight away. So to avoid this, what we wanted to do, we have a polar dag in between, which will poll on this request on database. So even if our control plane orchestrator, that is again an Airflow instance, if it is down, once it is come back, it will again start polling on those requests. So there may be a simple delay for the customers, but it is sure that they are going to have their instance after some delay.
Right. Right.
So that
Yeah.
is one of the reasons. Yes.
Okay. So we have a lot of questions actually. Ahmed asked, what is the metrology service?
So it is a service we push our logs to. So we
Right.
create this is internal service, and we create different pipelines, and we use a log shipper to push all our logs to this metrology service, and from there we can give this access to all the customers to view the logs.
And do you use anything under the hood, like logs via Elasticsearch or something? Or
No, actually, we are pushing our execution logs, that is DAG execution logs, to Amazon S3. And for process logs, we are using, as I said, metrology.
got it.
So customer will have access to both of them, and yes.
Right. So yeah, another question from Ahmed: why are you not using Kubernetes executor instead of Celery?
Okay, so we are planning to use. So it is under study. We are in near future we will be using Kubernetes executor.
Right. So just to expand to that, Celery executor is more stable for you right now.
Yes. So for now, yes. With for our service, it is stable. Yes. And we are also doing some studies on new version of Airflow, that is 2.0. So hopefully we will leverage all those features which you explained, Kaxil. So we are excited.
Nice. Yeah, I think we still have time for a few more questions. So Manoj asked, like, why a custom trigger diagram operator and not the default one?
Okay, so actually, if you see out of the box trigger diagram operator, at the same time, it cannot trigger more than one diagram. So suppose for our control plane API, if we get two or three multiple simultaneous requests came for the same actions, suppose for create, with the out of the box operator, we cannot do this. So what we have done, we have made a custom trigger diagram operator, and we use this um, loop over this we loop over these requests, and then we will be able to schedule all these diagrams at the same time, even if it is for the same dag. So that
Right.
is the purpose behind it.
And do you Do you publish it to all of your users via Python package, or is it just available as an internal module? Or
Sorry, can you please come again?
so that your custom trigger diagram operator, do you
Mhm.
give the Python file to all of your users, or do you like publish it
Yes, so,
via?
so actually, we have a kind of a community inside SG. So we have a Git repository where we will be having commonly used plugins or operators or sensors. So like this. So we will be that's a public repository internal to SG, and anyone can consume it or they can contribute as well. So that's why we call our customers as contributors. Not as end user.
Right. So I think you are already answered this question, but if you want to still again clarify.
Great thoughts in UI. Are you planning to make an open source and make as an open source? And what is the stretch or framework? Yes, so we are planning. So it is still under development. We have different frameworks and technologies to see. But currently, we are using, I think, Angular. So that is actually not finalized yet. So once it is finalized and it is production ready, we would like to contribute to community.
Right. And I think let's make this one the last question. So how you manage it to sync your decks every time there is a change needed to trigger a new deployment?
Okay, currently actually we have to trigger a new deployment, but we are working on sync operator, sync feature, that is to sync a Git repository or an Amazon S3. So we have two options here again. So it's up to customer how to sync it. I mean, it is to sync all the time or not. Or in the production, suppose if we have a new DAG, so if it is syncing automatically, so it will cause an issue. So yes, for this we are developing this feature in the current sprint to have auto sync from Git repository and Amazon S3 also.
Awesome. Yeah. Thank you, Jilan, for awesome presentation and answering all these questions, and loved it.
Thank you very much, and thank you, Kaxil and Sumit, for organizing this after such a we know how it was 2020. Yes, it's a great, and thanks for this opportunity to present at this meetup. Thank you.
It was
And
pleasure to.
I forgot to mention, so we're also hiring. If somebody is interested, please send your resume to me or LinkedIn or however you like.
Awesome.
Thank you.
Then introducing the next speaker, Amit. Hey,
Hey,
Amit.
Axel. Yeah,
Nice
thanks.
to have you. Amit is the senior SWE at InMobi, and he's here to talk about Oozie to Airflow. Over to you, Amit.
Sure. Let me just share the presentation. 1 second. Can you guys see the screen?
Yes.
1 second. Yeah, Axel, can you see the screen?
Yes, I can. I can. Yes.
Sure. So, first, I would like to thank everyone for joining this session. So, let me start with a brief overview of what this session is all about. So, we're majorly going to talk about why we at InMobi migrated our workflow manager from Oozie to Airflow, how we are using Airflow for our orchestration needs, the challenges we faced, and also briefly talking about features and dashboards that we build over it. So, let's get started. So majorly this session is divided into the following sections: that how we were dependent on Oozie, what motivated us for the change, why we chose Apache Airflow, what challenges there were, and how we're deploying the Airflow in current setup. The features and plugins, and the cost and resource dashboard that we have built. So first of all, starting with how we were dependent on the Oozie internally. So InMobi, being an ad tech firm, hugely rely on data for each penny we make. So we used to have like hundreds of TBs of data sitting on physical storages, getting processed continuously, and so on. So these there are hundreds of pipelines that they are running, summarizing data every hour, and all of these things were done by our orchestrator Apache Oozie. So Oozie, there were a lot of code written which dynamically generates workflows using Falcon and Oozie, and the centralized Oozie servers used to do all the heavy lifting of this scheduling. Uh, Now, what motivated us to change? So, in the past couple of years, InMobi went through a tectonic shift from physical machines and storage to the Azure cloud. Uh, Although Oozie was able to cater a few needs in some shape or form, but it was not a lot of cloud ready at that point. So we had this as an opportunity to switch our orchestrator from Oozie to something that is more popular or more cloud ready. Also, moving forward, the division of verticals happened inside the company, which leads like different teams were formed, and everybody wants their own cluster to run the jobs and not the centralized one, so that they can easily track what all costs they're causing and what all resource they're actually using. Also, the Oozie's UI was very simplistic and have only few read-only features. There were few alternatives like Hue, but that will again come up with their own maintenance overheads. Oozie comparatively have a very small community. I think only less than 20 contributors, and not a big community for the support for your support needs. Also, workflows to be written in XML and using Oozie client comes up with its own learning challenges, and we have to make sure that everybody is familiar with the XML encoding. And also, they discuss that if we want to distribute the clusters for everybody, we need a new setup, and we had to do it on the fly. So the setup of a new cluster was becoming a little painful with our existing Oozie setup. Now, why did we choose Apache Airflow? So Apache Airflow comes up with almost all the cloud needs that can be there, and there are various connections. You can have Azure storage connections and AWS connections around, so that almost all your cloud needs are satisfied. Complex pipelines you can write as I think Vivek already showed that a big pipeline that he has written. So you can write easy complex pipeline, just give the task order, choose from the sea of existing operators, and you can do almost everything there. uh, and also adding a new operator, although there are many operators present in Airflow, if you even want to add few new operators, it's just like plug and play. You can just put it in the plugin folder, and Airflow will take care of the rest of the things. Airflow also has a very huge community. It will have like almost 500 members and more than 1400 contributors in Apache Airflow, and which gives you a sense of support that you will get all the support that you need. Also, Python was a very popular and uh, easily usable language, and almost everybody is familiar with this language. So writing in workflow and telling the clients to write a Python workflow was not a very big deal breaker. Also, there is no denying the fact that Airflow comes with a very rich web user interface. It can show you logs. It can give you you can rerun your DAGs from there. You can see the DAG definitions. Also, there are plots of graph from the UI that you can see. So these all things actually made us to have Apache Airflow as an orchestrator in our premises. Now, some migrating of this scale from Oozie to Airflow comes with its own challenges. So, as already discussed, we wanted the segregation of clusters for all the teams. So we should be able to like deploy a new Airflow cluster on one touch, and just click one place, and you will get an Airflow cluster for a client, whoever needs one. How we can make our clients to deploy a new workflow, how we can we can make sure that they don't bother a lot about the internals of Airflow and easily just upload their own Python files, Python DAGs, and get over with it. The third one is that Oozie and Falcon comes with a concept of input. So almost all the coordinators, all the jobs that were there were waiting for some input to be present, uh, as they consider inputs as an integral part of their service. So we need to come up with a solution in which we can make sure that Airflow also cater all that needs, and it can wait for n number of inputs to be present before the real execution starts. There were also some extra features like replication and retention and many others for Oozie, that these are the ones that we use very explicitly. So replication and retention, something we need to build around in Airflow. And there was also one other feature that Falcon has come up with, which was late retry. So we will discuss it later, but it is more like if any of your input changes, your pipeline should run automatically so that the freshness of data is intact. Also, we wanted a proper segregation from workflow manager and compute. So we don't want our workflow manager to do all the heavy lifting or of actually running the jobs. We want that to run on a remote compute yarn clusters. And authorization and authentication is anyway necessary everywhere. So first of all, let's see how we deal with the challenge of deployment. So how we have come up with the deployment strategy is that we divide our ecosystem in Azure Kubernetes services. So you can consider like one AKS for a team, which will have all the required number of compute clusters and workflow clusters. So that, and these are deployed by our provisioning microservice, which can just deploy all the required YAML files for Airflow, and the deployment is seamless. Web servers, workers, and schedulers all are deployed in separate pods. Web server and scheduler we have deployed as sort of deployments, and workers are deployed as stateful sets for the scalability purposes. So we want that we can on the fly can should be able to scale the workers if we need. So yeah, those are deployed as a stateful sets. We are using Redis as our message broker to just make sure that all the workers get the tasks that are scheduled by the scheduler. The configs, how we store it is in the Kubernetes config maps. So all the Airflow.cfg content we used to have in config maps, and it's just we can once the pod comes up, this all these configs will get copied into our Airflow.cfg, and so that we can easily edit those configs for all of our pods together. Also, various dependency packages we need for the operators that we have built. Some Python packages needs to be installed. Those are also comes along with Kubernetes config map in our deployment scenario. This is a simple control plane, how it looks like. So this, consider it as an ecosystem given to a team. So that team can have one workflow cluster or more, can have to compute, and this workflow can make sure that it can run a job on any of the compute clusters. You can see here, you can go and see all the UIs here, which are possible. RM UI, you can see Airflow Web Server UI, Flower UI. It's just one touch, and you can just see get redirected to this UI. You can also see that from the UI itself, you can just go ahead and add the cluster, and a few configurations will be required, and you can should be able to deploy a new YARN computer as well as Airflow cluster. So how does we actually orchestrate via Airflow? So this is a second part. So the DAGs, as you know, that there are separate number of pods, and we need to have the consistency in the DAG file. What is a DAG definition? So we came up with the solution of putting those files in an Azure file share and mounting all of these into the Kubernetes pods for the consistency. So once you change these DAGs in one place in the file share, in every pod, that change will get reflected at that point of time. Jobs can be easily configured by just one configuration. So we have put it as a operator level, that you can just put your YARN cluster name. As you can see here, you can give, let's say, bidder as a cluster name, and rest will take care of scheduling that into the compute cluster that is provided. And also it can run on the workers for normal bash operators and all. It can run on the worker also, but major compute should be carried out by the yarn cluster. Templatizing, as it is a Python, so you can just have a DAG generate code and which can dynamically generate your workflows for you. Also, clients can scale workers using control planes. So you can just go ahead from the workflow manager itself. You can just uh, scale up the workers if you want. If you want to upload more of your DAGs in it, and you think that the current number of workers will not cater your needs, you can just go ahead and change the number of workers here. Also, the REST API is supported, which can take care of deployment, of refreshing your DAG, triggering your runs, clearing it, and so on and so forth. So this is a basic how the DAG execution takes place in our system. So Airflow just submit a job to our job submit APIs, and it then asks the cluster manager that what is the corresponding yarn cluster to run for this job and for this name of cluster, and it will just return you with all the details it requires. So this is how we make sure that the Airflow and computes are separated and segregated. Now the one more big task was how to ensure the authorization and authentication in the current environment. So there are three set of things where we need to implement the auth. One is their web server UI. So Airflow comes with just a simple configuration RBAC, which you can just set true or false, and it will come up with a default username password RBAC enabled. There are multiple OAuth providers that you can use, which we in our system we are using Azure OAuth to do that. So in Azure OAuth, also by the Fab Security Manager, we can make sure that we have coupled it with the Azure AD groups. So while the cluster creation, you can specify that these are our admin groups and whoever are part of these groups, so that you don't have to manually add every time a user as an admin. You can just give a group name, and that all members of that group will be considered as the admin users. So that is one way of authentication we have done. REST API plugin also needs to be authenticated, as it also have all the capabilities of deploying and triggering a DAG. So this is all, and REST API is accessible from two places. So from web server UI, it is easy as it is already being authenticated. Also, if you are doing it via curl or postman, the same flow goes like with from the Azure AD groups. If you have those proper privileges, you will get the access to submit a new DAG or do the activities from REST API. DAG deployment. So deployment is done in two places. So you can have we have a proper CI/CD pipelines built, so that you can just by even one touch, you can just put all your DAG files into the file share, and the Airflow will take care of the rest of the things. Also, REST API plugin is anyway authenticated, and even if you are going through deployment via REST API, it is totally safe and secure. So this is a simple login window, how it looks like once you go and log into our Airflow web server. It's just a Microsoft icon. You can set it as a provider, signing in, and it will take you to a window if you have the proper privileges. If you have the admin access, you can have the REST API plugin, as you can see here, that you can do all the API activities through UI itself. And you can have multiple things like security management and everything from the admin window itself. So this is something that comes handy for the authentication purposes. Now I would like to shed some light on features and plugins that we have built. So first thing that I already talked about was that Oozie has a capability of waiting on certain sense of inputs. So Airflow does come up with a feature called sensor, but we needed say a sensor which can sense all the jobs in a batch mode. So we built this sensor which can cater configurations like start time and end time, and can have multiple input names, input paths, and based on that time range, it can get list of all the paths that are actually valid paths, and just wait on those paths before starting any job. So you can just put the sensor at the start of your DAG, and this sensor will always wait for all your paths to be present before the real execution starts. The second one is Spark operator. So there's a question that why don't use the inbuilt Spark operator. So as I told earlier that we want that segregation of a workflow manager and compute cluster. So we want that as 90% of our jobs are Spark jobs. We wanted here that this operator normally just creates a Spark submit body like Livy, and add a cluster name and just send to job submit API, which then takes care of transferring it to a respected Livy server and get it executed. So this is the layer in between that we have built to run our Spark jobs. Replication operator is nothing but it just copies the data from source to destination. So to make the life of client easy, what we have done is we just wrote the replication code in Spark for Spark ourselves, and just make sure that you can just pass source and destination, and you can just replicate your job by the code that we have written centrally. The other operator that we have built is one is retention operator. It just, as the name suggests, it will just delete the paths which have gone stale or whose retention period has been executed. It can delete all the paths in bulk and get over with it. Late retry sensor, as discussed earlier, the goal is to make sure that once any input of the pipeline changes, all the workflows should get re-triggered. For this, the solution what we use is to couple the DAG with a sensor, and this sensor will keep on looking at the timestamp in the reschedule mode, and just go ahead and rerun the rerun the corresponding execution time of the DAG if there is any change in the input that occurs. There's also a interval in which only we can assume that the input should change. We cannot keep on checking for the eternity. So in that period itself, if it changes, it will just rerun your existing jobs. Kubernetes pod operator, it's nothing but the Kubernetes pod operator provided by Airflow itself, just making sure that all the packages and all the operators are there where all the packages are installed, and the image is exactly as worker, so that this pod doesn't have all the things that are required. So this is just as simple as that. Now moving forward to cost and resource dashboard. So after all this division of cluster and ecosystem, the next goal for us is to actually know how our each job is performing, what is the resource usage, what is the cost estimate, how the cost is growing, and so on and so forth. This dashboard actually helps the client to keep tabs on their jobs. So you can see all the cost in an average manner, as well as at an instance level, that what is the cost of DAG at a particular instance. Even it is more granular, and you can see even the task level metrics and all those in the dashboard itself. It also shows the waiting time metrics, like how much time it waited on Airflow cluster, how much time it waited on the Yarn cluster. And it also plot you a proper cost and resource of DAG with respect to time. So this is how the normal cost and resource dashboard looks in our system. So you can see here, here are your DAGs. You can see what is the average cost of that DAG, average cost as in per instance, how much cost it take, the VCOs, the GVs, all those things will be present here. Average waiting time will be there, that how much it waited on Airflow, it got scheduled in Yarn without any delay, and those all things you can track from here. Now, also if you click on one DAG, you will see the task level metrics here, that each task, how average cost is there, and also you can see how the plot goes from for the DAGs here. There's a Airflow link which will just take you towards the tree view of through the Airflow UI itself. So this dashboard helps us keep the track that how your cost is growing with time, and if we need that, if the client needs, they can just modify a few configurations to get a better cost, and they can try and test things out, that how can they minimize the cost that is there in their cluster. So more or less, this suffices all the content that I have. So we what we achieved here is we achieved one-touch deployment for Airflow clusters. We achieved how we can how the cost is visible and how we can analyze all the resources and cost. Uh, how we can be secure in all the Airflow terms, and how we can easily scale the workers as per the need is there. We can submit the jobs to a new yarn cluster, and what plugins that we needed to replace the basic functionalities of Oozie, so that we don't lose any capabilities here. So yeah, that's it from my side. We can take questions now.
Awesome. That was a great talk, Amit. I myself have a lot of questions. So let me start. So first question was like, how do you monitor your deployments currently?
Okay, so the deployments, all the deployments goes through control plane itself. So we can just go there, add a new cluster. We have our provisioning services that are maintaining all the logs, and this is so right now, yes, full Kubernetes services set of deployments that we have to monitor, and others if you're adding a cluster, that is via control plane itself. So those are things you can do from control plane.
So under the hood, do you use like Prometheus, Grafana, and
We use Graphite and Grafana
okay.
for our yeah.
Right. And yeah, like are your Airflow deployments multi-tenant? That is, multiple teams use the same deployment, or does each team have their own like deployments?
Yes, so normally the teams which are segregated, they have their own deployment, their own AKS clusters. Even inside a team, it might happen that there is subdivision and they can have two different AKSs around it. One ecosystem, one team, what it looks like is a n number of workflow and n number of compute cluster under a single Azure Kubernetes service. So yeah, which we do not do a inter connectivity between the two AKSs of let's say one team's Airflow cannot submit a job to a other team's compute cluster. So
Right.
as of that is not there.
Right. But if they're using the same deployments, like how do the DAG deployment story work? So are the tags baked inside the Docker images, or some kind of mounting happens
Yeah,
somewhere?
so we do it via Azure file share. So you have an Azure file share, you put your DAGs there, it will be mounted across all the pods in your Airflow environment, in all web server, scheduler, and worker pods.
Right. And so I assume the users are directly uploading the files to the Azure file system.
You can do it via your deployment pipelines that are there. You can just sync it through GitHub, and those files can go ahead and sit in the file share whichever you provide.
Right. One question from Vishesh. How are the new operators getting added? You mentioned something about using plugins.
Yeah. So right now, how we are doing this is that we do maintain all these plugins centrally. We as a platform team build all those plugins that are required. The request comes and we build the solution around it. So, and whenever a new upgrade of Airflow cluster goes, then what we do is we will just so these plugins are made in a Python package, and that Python package will get installed directly to your Airflow cluster. Whenever you upgrade, you can just upgrade the version of we go it via Airflow utilities. You can just change the version, and then it will get deployed there itself. The new
Got it.
plugin get added. We don't have a central plugin system where people can contribute, but yeah.
The cost and resource dashboard was amazing, to be honest. And like I had a question about that. Like, is it real time? Like, are the metrics updated in real time or near real time?
So how we are achieving this is it's real time itself. We do it through a post execute call from our task itself. So whichever task is there, if from post execute, it will have the application ID, get all the details, and just push it to the matrix, push the metrics to the dashboard.
Right. And like, related question: how do you like calculate average cost per DAG? And you had drill down still task level. So I'm just
So we
wondering how it
have
works.
levels and more or less summation of all the task goes to the to your DAG cost, and whatever time range you select, you can just have number of instances and what is the average DAG cost you can calculate based on that. The cost can be calculated based on the resources that it's using. So we know what are the VMSS costs as of now, what part of VMSS it is using, and we can calculate the cost based on that.
Right. And what happens when like no tasks are running and the workers are still sitting there? So there is a time where a user might still be incurring the cost because there are workers, but they are not running any task.
Sure. So that will be so that is where the segregation of so airflow cost will always be same because number of VMs will be running same, number of workers will always be same. But the compute we have a we normally have a auto scalability there. So for the compute, it will not be incurring cost if no jobs are running because no VMs will be requiring at that point.
Right. Like you almost answered this question. Like, do you have scaling dynamic? You have some sort of auto scaler, or users can scale it on demand, like increase workers,
No,
decrease.
we have an autoscaler build where you can user can have like min and max value of nodes that they want on the VMSs, and but the scaling we do is dynamic auto
Got it.
scaling.
And one question from Joy: did you use any automated tools for migrating Oozie workflows to Airflow X?
Uh, no, because when we were in deploying all this Airflow, we are going through this migration. It was we did have few sessions on how to build Airflow, but it is quite straightforward of writing our tags and it will also not be one-to-one mapping properly from Oozie to Airflow. There has to be few config changes that were always required. So that is a learning that we as a team have provided all across all the premises.
Right. And when are you upgrading to 2.0?
Yeah, that is actually part of our charter, as in most probably like next this quarter and or next quarter we'll do that. That is in the plans right now. But as you said, 2.0.1 looks better, I think.
Yeah. I think 201 contains a lot of bug fixes. So instead of migrating to 2.0, you should just migrate to 2.01 instead. Yeah, it was a great talk, Amit. Thank you very much. And thank you all for asking all these questions. Now, let me call Sumit and Jilan too again, just before we say you goodbye.
Okay, I think yeah, that's at the end of this meetup, and I just want to thank again for all the presentees, Kexel definitely, and all the people who joined on our YouTube channel. Just look out for the next meetup. I hope that this time it would be soon and not after a 1 year gap. Yeah, so feel free to reach out to reach out to us. If you want, if you guys want to do any next meetup or want to talk in the next meetup, yeah, there will always be a slot for you guys. Thanks, thanks everybody.
Thank you, everyone.
Thank you, everyone.
Speakers too. Bye
Thank
bye.
you. It was amazing.